Okay, thank you very much for the participation. We are here to open the final event of the MARBEL project. A few words before on the place where you are. We are in CRF. Probably most of you know everything about it because it's a main actor in the European context of research from the late 90s. So we have pretty long experience in the collaborative research under the umbrella of the different research program. MARBEL was born almost 5 years ago. It had the ambition to build or to study the battery pack for our vehicles. So it was almost one of our first approach of tackling these components, the central core gravity of our vehicles. So we are here today for showing the advances that the project did and try to also have a bit of discussion about the achievements, also to pave the way for future development, always in the collaborative context, and also for showing to my colleagues the achievements in order to pave the way for the adoption and commercialization. So what to say? I want you just to scroll a bit the agenda of the day. So we'll have an opening plenary where I invited my colleague Nello Lipira that will speak later, Edward Piqueras, that is the coordinator of the project, that will show all the scheme of the objectives and the work done and workload and the result put together in these 4 years. So the project started in its concept 5 years ago, so pretty much water has passed, and now we are here to collect the full thing and show you the results. So, what to say? In the next slide, so we will have the agenda here, an opening section, another 4 technical section where some of the players or the partner will show specifically by discipline the work done in the achievement. Any section, there are 5 minutes for question and answer. For the people that is remotely connected, I've been told that they can chat directly the question, and the moderator would collect them up and direct these directly to the speakers. And for the other people that are here, can simply raise a hand, and someone coming with a mic, and you can directly address the question to the speakers. So actually, what is written here? So I give the stage to Edward Piqueras, the MARBEL coordinator. And so.
Okay, buongiorno tutti, good morning. And well, special greetings for all fathers in the room because of today. I think me and also in the name of all of the MARBEL team, we are very happy to be here today in Centro Riserche FIAT, in one of the innovation, the most important innovation poles in automotive industry in Europe. So it's a pleasure to be able to close the project these last 4 years of work that we have been doing, and that today we will present to you in this Centro Riserche FIAT in Stellantis Group. Well, my name, as you say, I'm Edward Piqueras. I work in Eurecat Technology Center. It's a research and technology organization with about 800 people, employees in the region of Barcelona. We work with several research and technology domains, from materials, digital technologies, etc. And in this case, we team up with different organizations in 2021 to tackle different challenges in the electrification of mobility. Okay, I will give you an overview of the project now, and the idea is that during today you will see presented by the different partners that we have in the consortia that you can see here, the different innovations that we have been working in these last 4 years. Okay, as you see, we team at different kind of organizations. On the top, you see the 6 research centers and universities. Okay, Eurecat in Barcelona, Carisma in Ingolstadt, Germany, Sintef in Norway, Fraunhofer-EU in Chemnitz, ICCS in Athens, Greece, and IREC also in the region of Barcelona. We also collaborate. We try to put together all the value chain in what's the automotive industry. So also including tier ones, as in the provision of extruded aluminium profiles, ABL as manufacturer of developer and manufacturer of batteries, Agrati for fasteners, Ficosa in the junction box. And then we also addressed the end of life of the battery, counting with important company with technologies for recovering materials from batteries, and also other engineering companies like OTC, PowerTech for the electronics in the BMS and communications, and AP Plus Idiada, one big automotive engineering in the region of Catalonia in northeast Spain that served on the last part of the project for testing. And of course, the reference of the end user, Stellantis, Centro Riserche FIAT, as the OEM of the project. Okay, the project started in 2021. We took 4 years from 2021 to this month, and so we are ending the project by next week. And it was started in the frame of Horizon 2020. Nowadays, it's called Horizon Europe. That is the research and innovation framework, funding framework in the European Commission. Okay, under the topic BAT 10, that I'm going to explain you a bit what was about this topic. The European Commission was asking to accelerate the mass market take-up of the electric vehicle, especially to contribute to meet the greenhouse gases European Union emissions reduction. So transport and mobility was one of the sectors with higher emissions, and the aim of the European policies were to reduce this to a target of 55% by 2030. So the European Commission sent a mandate to build a consortium projects to tackle these topics. Okay, accelerate the mass market take-up, but with the development of more sustainable and efficient electric vehicles. How we propose it to do that, or which are the ways to do that? By increasing energy density, so especially reducing the weight. And this project is focused on reducing the weight, excluding the cells, so all the systems and housing structure of the battery, optimizing the battery system's performance to enlarge the battery range and the battery lifespan, reducing the charging time. That would be critical points on electric vehicle end users. So try to give them more range and less time for charge, and increasing the battery lifespan. Okay, tackling the degradation of the cells. So getting an enhanced performance, especially in what concerns the thermal management. Reducing also another of the goals, or how to tackle these goals, was reducing time and cost for manufacturing, maintenance, repurposing for second life application, and an overall objective, MARBEL tried to develop more sustainable batteries. Okay. Here you can see the KPIs we focused at that moment on a benchmark reference on the segment of SUV, the Audi e-tron, 95 kilowatts, and these were our KPIs for reduction of weight, increasing the lifespan, the charging time, LCA, and times and cost maintenance. This is how we do it, and the details you will see today during the presentation of the different sessions. In session 1, you will see all what concerns on the design for facilitating the circularity and the repurpose of the different components of the battery, making the battery modular, scalable, but also modular, easy to assemble, disassembly, lightweight, using recycled materials also to reduce the environmental impact of the battery, working with weldless connection, weldless bus bars, wireless communications. Well, you will see all these eco-design strategies, how also we thought these eco-design strategies, which kind of methodology we implemented to tackle those actions that can get a major impact in the battery. After this, in session 2, we will talk more on the performance of the battery. how we enhance the thermal management, how we work on strategies of ultra-fast charging that doesn't reduce the performance or reduce the life or degrade the battery, the way of managing the battery, so the brain of the battery, the BMS, the use of wireless communication, etc. All this will be explained in session 2. Plus we have one of the partners working on a data-driven digital twin for prediction of degradation in the battery. Okay. This finally in session 3, we will present some of the results of the tests that we've been performing with the modules and the battery pack, and also the platform for testing that have been developed or as an innovation by our colleagues in IDIADA. Okay. You will see all this, and finally, after in session 4, you will see also an overview of what have been done in the other sister projects we call from the same call. So in the same call that European Commission asked for tackling these challenges, there were also other 3 projects apart from us working with other OEMs, Mercedes, other OEMs and other approaches to tackle all these topics, lightweighting, thermal management, etc. And they were invited today to show you also their perspective and the innovations that they brought. This will be presented in the last session. Well, as I commented, we started in 2021 setting up the requirements for safety, modularity, etc. And then we developed the solutions and we designed the modular, weight optimized and high performance battery. And this took us you see there like iterations around a cell, because we have some changes on the course of the battery from the initial cell we were working with to the final cell we have been working. Okay, we keep it the geometry, okay, because the concept of modularity and the concept that we have, but we changed it, and this made us a bit iterate until we had the final design ready to manufacture and then validate. You have to see the battery. You will see it's here in CRF, but in another building. It's a prototype, so it's not a battery ready to be put in a car, but it's a place, a bench for testing how the different innovations that we put in the battery, the different eco-design actions, enhance systems to enhance thermal management, to permit ultra-fast charging, etc. How they perform in a real environment. Okay, but you have to consider you will see it as a prototype. Okay, well, what we expect to get, or what impacts we expect to bring to the industry and to the society, is, as explained before, the goal of fostering the acceptance of user electric vehicle, tackling this anxiety range and these concerns of the final user, or on what concerns the charging time and the range of the batteries, to get more autonomy on the vehicle. Okay, and then also it's a very important point for us, the sustainability of the electric vehicles. Okay, doubling, enhancing lifespan gets us reduces the impact of the batteries, but also working in all those aspects of the design of the battery that permits to enlarge the life of the battery. So, and also the materials and the components that takes part in the battery, not only for the life in automotive, but for the repurposing in second life. Finally, all this electrification of the mobility in Europe looks for, or have the goal of reduction of emissions, and is aligned with the new industrial strategy for Europe, circular economy action plan, the new directives on battery, and the battery passport, the circularity of the components and materials inside these components, and finally the reduction of the greenhouse gas emissions in the European Union, especially in the transport sector. We also aim to, and we are bringing new pool of skills for European battery design industries, and also all these tier ones and sectors are working also in the BMS functionalities, and the industry dedicated to dismantling and recovery of materials. We are trying to save costs, time and cost in what is assembly, maintenance of the battery, and also the testing. Okay. What we identified as future trends or future research needs, at least on what concerns this circular battery market in Europe, in the part of the materials, or especially in the housing or materials like the aluminium. It was announced recently by the European Aluminium Association. Well, there is a shortage of raw materials, and there is also a scrap leakage in Europe. So it is important that it can be that we work more in the part of scrap sorting processes to enhance the use of recycled materials. In terms of EURECAT, in this project, together with us, as we worked on increasing the percentage of recycled material in aluminium alloys, and we also work this in other projects in aluminium and also in steel, what concerns steel. There is need for standardized interoperable track and place platforms. So this is to get traceability of where the materials came and where the components came, ensure adherence to environmental and human rights principles when making purchase decisions here in Europe, and also providing critical information for facilitating the reparability and the reuse and repurposing of the components. So enlarging the life of these components to further applications further than the automotive life. The access of standardized data about state of health and design. So this is also important for facilitating the repurpose and second life, and also facilitate the responsible movement of batteries. So to build a real circular battery economy, there is need for facilitating the transport of certain components, active components, especially along the different countries here in the European Union. Well, batteries are an exceptional asset for humanity, but the time to act and make them really circular and don't have leakage of materials and don't have a problem of waste in the next years, I think we believe it's now. So, well, with this short introduction, I think it's time to see the video of MARBEL. Okay, well, with this nice video we prepared it especially for this event and closing the project. There will be an extended one that will be published also by the end of the project. Well, I just wanted to say that during the event for us it's very important to collect feedback from potential end users of the innovations or people or players in the sector. That means tier ones working with BMS, with materials, OEM, etc. The perspective of the people, players in the market is very important for us. We will have a QR code, okay, that we will show in the screen during the sessions with very short questions like, what do you think it's a risk, opportunities for adopting this? Do you think this should work well? A bit to collect this kind of information. We'll try to collect it also during the coffee breaks, etc. And I really appreciate if you can give us this perspective and this input. Okay. Well, now for the next presentation, Daniele invited. Thank you, Daniele.
Thank you. Just a couple of words about Nello, physicist. He did his PhD in the old CRF where the nanotechnology was born, trying hopping electrons from quantum dots, metal to metal. So we're tracing back 25 years ago. Now he grew up bit by bit, and now he's the global chief of material for electrification of Stellantis. And I hope he can give you a snapshot of where the company is going, the perspective of growth, and the impact that the electrification has on our business, that I hope will pave the way for future collaboration, topic by topic, with all of you. So the stage is yours.
So thank you very much, Daniele. Thank you very much to everybody. So welcome here in CRF Stellantis. Today I'd like to give you a different overview from the battery pack, because we call it battery pack, but I try to give you a specific presentation focusing on the topics of raw material. That is quite important for energy, and it is also important, so we the impact in the battery pack, and probably it is the new challenge that we have as OEM for the future. This is the outline of my presentation. I'd like to give you, first of all, Stellantis in short. So what is Stellantis? Because we are CRF, but we are 100% or 99% Stellantis. And I'd like to give you a vision of Stellantis, of our strategies and roadmap for the e-mobility. Then I'd like to go in detail in the case of lithium-ion batteries, because I decided to take this case study. And I try to give you an overview of the issue and the challenge that we have for raw material for the battery cell. And finally, the design for a battery of the future, and the conclusion and wrap up. So as I told you, Stellantis. So CRF and Stellantis. Stellantis is basically a company that merged together two of the biggest automotive maker. So I mean PSA and FCA, and with FCA CRF. So we merged together with our colleague in France. And basically now Stellantis is in charge of 14 brands of passenger car. Here you have all our brands. So we produce this car starting from segment A, so low car, and up to luxury vehicles, so up to Maserati. And so basically we have a worldwide organization. In this worldwide organization, we are material engineering. We are a group of material that basically we have a three soul merged together. One, material engineering, because we are in charge for all the material that we have in our vehicle. Second, we are a new team named Sustainable Raw Material, because we are also in charge for the raw material, so the new vision of the company. And third, we are also in charge of innovation, and this is because we are CRF. So we merged all together these three souls, and now we are at the global level organized in three main technical team that are polymer, metal, and material for electrification. As you see, so when we're talking about material for electrification, we have batteries, we have a fuel cell, we have EDM, so electrical driving motors. So we have obviously metal and polymer, because are two material. The difference, what is the difference? Let me say that for metal and for polymer, we have the traditional approach to this material that we have in car making. In my team, so in the team of material for electrification, we include all the material that enable the electrification with the new functionalities, with new performances that in the past we didn't manage, we didn't control, but now due to the electrification, we have to manage, we have to control. I'd like to start with, as I told you, with some figure of the company. Exactly, these are the rollout, so the expectation of the company, the target of Stellantis company up to 2030. This is the plan that we have that is named Therefore by 2030. And as you see here, we have a huge increase of the battery electrical vehicle portfolio, both for European market and US market. And you see that we have different BEV at different levels. So luxury brand like Maserati, like Alfa Romeo, like DS, Jeep, premium brand, and all the brand in Europe, and there are the smaller ones like Fiat, Citroën, or Peugeot. How we can achieve this target? Basically, this is the strategies of the company. We started to have basically simplification, so make easier the things. So simplification of our vehicles. So we decided to have a for new design for platform, small, medium, large, and frame, and basically 3 different EDM that are the electrical driving motor. When we start with this, that is a simplification, obviously we want to converge to the battery electrical vehicles, so to the production of the batteries and the EDM. And so we started to have some joint venture, because in the past, so 10 years ago, we didn't produce batteries, we didn't produce electrical motors. So we must start with some joint venture. And here you have the name of some joint venture of drive motors, so e-motors, and battery cell and module. So e-powertrain for the so Nidec, so e-motors for the electrical driving motors, and the joint venture for the production of batteries are ACC, LG, Samsung, and now CATL. Different, as I told you, we are worldwide company, global company. So some joint venture are for North American market, other joint venture are for European market. But we don't stop here. So we wanted to go ahead, and we started to have also some investment in, obviously, in innovation by us, but also some agreement and deal with company, startup for the future design and the future technologies. But not only, the company started to invest in the raw material. And this is exactly why I told you at the beginning, we have a free soul, and the second soul is exactly the raw material management and monitoring. Today, Stellantis has agreement with some project and some company that produce raw material. Here you have some picture of a company like Vulcan for lithium hydroxide, nickel sulfate, copper, or graphite. So this means that we have some agreement with this company in order to produce for us the raw material. And this is exactly the complication that we have, the challenge that we have for the future, because we are not more the OEM, so the final customer, so the final producer of our components, but we are always the final producer. So we have the owner of our components, but we are also at the same time the first supplier of the raw material. So this is change also the paradigm of the production. But get a look to the, so if we have a comparison between combustion engine and electrical vehicle, we have a strong differences. As I told you, we have to change our paradigm. We have to change our paradigm not only due to the different supply chain, but also due to the vehicle itself. We have, obviously, if we have a comparison, the electrical vehicle is a benefit in intrinsic CO2 emission, and this is obviously. But we have worse situation in case of dependence of raw material, because we have a strongest dependence of the raw material, and we don't have any supply chain when we're talking about from raw material to the OEM, because we are building up. So we are working on that in order to align and address our supply chain of raw material to automotive market. And finally, we have an architecture and a complexity that is, in case of battery electric, that is easier because we have not managed the combustion in a vehicle. Obviously we have to manage the energy storage, but not the combustion. So it is make the thing easier. So let's go in the figure. So if we have a comparison between material, so between combustion engine, so traditional vehicle and electrical vehicle, you see that we have an increase of raw material inside of the vehicle. As I told you, we have a strongest dependence of the raw material, and this is forced us to invest in the raw material. So this is the reason why. And here you have an overview. Basically, in the combustion engine, we have copper, we have manganese. Here we have also graphite for the anodes of the batteries. We have nickel for the cathodes. We have cobalt, we have lithium, we have rare earths. An increase of the rare earths because we have the electrical driving motor and for the main traction. So we have a great amount of the rare earths, and we have also other raw materials. So you can contain that we have 6 times more of the precious material than in the past. And this is quite important, quite crucial, because we have to manage this material in order to maintain the cost of our vehicle. But the cost, material cost, it is not only our challenge. We have to also manage the growing demand. We also have to manage the environmental concern. We have to manage the supply chain, the human rights violation, because this is quite important. Because if we starting to manage the raw material, it is not only a case of performances, but we have also to take care about cost, obviously, also about some other aspect. We know that in case of thermal separator, we have mica, and we know exactly that we have some issue in extraction of mica. In the material, we have nickel, manganese, cobalt, and we know that are quite well known that there are some issue in the extraction of the cobalt. So we have also to manage this ESG issue in our material value chain. In the past, we didn't do. So with the vision of the European Commission, we can say that we have a map of the material, and obviously many of our material are in this vision are critical. Critical not only in terms of shortage, but as I told you, critical for many regions, critical for geopolitical region, for human rights, for maybe oscillation and variation in the cost, and other issue. One of the issue is the refining, because if we have the possibility to have offtake of material, but then if we need China or some countries in order to refine this material, is basically we always have a bottleneck. So we don't solve the issue, and this is one of the issue that we have. For instance, in terms of cobalt, we can extract in Africa, but then approximately 80% of the refining of the material are in China. So we have a great issue to depend on this market. So what we are doing in terms of company, as I told you, we're trying to manage all these issues, and we're starting to invest in the raw material. From technical point of view, this means that we are increasing, we are investing in our skill and in our competence in order to manage not only the performances, not only the properties, but also the raw material, and we're starting to push our material in the value chain. This is the different approach that we had. Obviously, this is the case of the battery pack. We can have or buy or make approach. In this case, for the battery pack, we're starting from buy approach with our supplier. So with agreement, we discuss about the performances, and we ask to design to produce for us the battery pack. Obviously, the trend and the vision and the target is to have a buy concept. So the idea of the company is, as I told you at the beginning, is to start to produce by ourselves the battery pack, to produce by ourselves the battery cells, and the same things is for the EDM and the electrical driving motor. Let's go in, as I told you, in order to manage the issue, we have to manage the production and to have really a benefit in this make, we have to manage all the value chain. Here you have a schematic vision of the value chain for the battery cell. As I told you, Stellantis started to invest in the raw material. So at the beginning of this line, with the securitization of offtake of lithium hydroxide, of nickel or manganese, then we are at the end in production of the battery pack, and we started to manage, to control, to have agreement in the value chain, because this can give benefit to Stellantis. So I mean, for the refining step, the precursor cathode material, the cathode material manufacturing, the battery module manufacturing, and finally to have our product in-house. In order to manage this material transformation, obviously we have to take care about the raw material, and as I told you, we have to increase our skill and our competence in the assessment of this material. Here you have a schematic of the critical material only for the cell, the battery cell, taking consideration that this is a case study. So in our perimeter, in the perimeter of metallization, perimeter of material for electrification, we have not only the battery cell, but we have also the battery pack with some new material that prevent, for instance, the thermal runaway. We have also the perimeter of the fuel cell or EDM. So this is a case study, but we can transfer the study to rare earths for the battery cell, to copper for electronics, or for, as I told you, for PGM, for a fuel cell and other kind of components. We are investing in what? We are investing in mapping, so pre-validation and quantification of the raw material in our components, but not only. We are also investing in new methodologies to validate the raw material at the beginning of the value chain. The case studies for the NMNC, probably you know that NMNC is one of the technologies that we have in our battery cell. NMNC means a crystal in which we have nickel, manganese, and cobalt in a different percentage due to the different energy density that we want. So 811 or 333 or 622, so different amount of these three different material. This is for cathode, and in particular, the advantage of this structure, of this crystalline structure, is that we have a layered structure in which the lithium ion can go through and release the electron charge. This is another technologies, because we have two main technologies that dominate our cell. It is NMNC, as I told you, but now we have also lithium iron phosphate, another crystal, another structure with other benefit. So we have a more stable situation, more stable structure, even if we have a lower energy density and electroconductivity. So this means that we can use one or another technologies for our vehicle, depending on the final target. So what we are doing, as I told you, we are investing in our competence and skill. Basically, we are invested in the assessment of this active material. In this case, you have a picture that has been taken in our lab of cathode material, and you see here that we have the crystal of NMNC with some additive that are in peak. So these are the different additives. So this means that obviously we don't want to manage only the raw material, but we have to manage also the different additives, the different active material that are part of our components. But not only for the cathodes. This is I forgot it. This is, we are quite proud because this is a picture that has been taken in our lab. And as I told you, NMNC is a layer structure. You see here exactly the different layer structure of the crystal of NMNC. So this is to show you, to say you that obviously we try to evaluate our material, but because we have a innovative DNA, we try to also to discuss with our supplier in order to increase the performances or optimize the material. Not only the cathode, but we are also managing the anodes. Anode basically is based on graphite. That is another raw material that we are securizing. In this case, there are a lot of discussion related to graphite, natural graphite, synthetic graphite, how to manage and how to recognize the two different kind of material. And obviously, we have also the issue on our desk about the anodes. So not only graphite as raw material, but anodes that are part, the graphite is part of this anode, but with some additives. So here you have the picture of graphite plus silicon that is an additive that improves the energy density of the electrodes. And finally, the separator and the electrolyte that are, again, two other material of our cell that we are characterizing, and we have some experiment for solid electrolyte. As I told you, we are working on that to support our supplier in order to have a pre-validation of the material, but at the same time, we are working to innovate for innovation to increase the technologies and the performances of our cell and our component. Finally, as I told you, I try to explain you the situation of the active material. So the material that we have in the cell, cathode, anode, and separator. So these are the part of the cell. But at the same time, we're starting to work with our lab on the raw material. So how to recognize, how to say that the lithium hydroxide, the nickel sulfate is exactly the grade that we want in our cell. Basically, we are working as material engineer, as material department, as material lab, in order to define a protocol of the qualification and pre-validation of this kind of material in order to introduce and speed up in the value chain and to speed up the production of our cell. So that's it from my talk. I try to give you a different perspective of the energy storage and then the battery cell, not starting from the performances like OEM, but starting from raw material. This is because we think and we know that these are the new scenario that we will have in the future, because if a company wants to invest in e-mobility, we can invest in new performance, in new components with higher performances, but we cannot forget the raw material, because the raw material are quite fundamental for the e-mobility. As I say, thank you very much. I see that you are quite active, so I appreciate a lot, and thanks again to MARBEL and to Daniele to organize this event.
Edward, please come on the stage. There are some questions. Okay, first, please raise your hand, and when I give priority to the audience, if there are any question here for our gentle speakers. No one? Try daring, take the trail to be the first. No? Okay. There are some questions from home. I try to understand the question further. It's not easy sometimes. Oh, also, because I'm becoming short-sighted, I hardly can read it. So, one for Edward. It's specific on your slide 12. Okay, you remember your slide 12? Okay, you said that the ambition was to cut the cost of the battery pack between 10 to 20%. Okay. The question is, considering that 8% of the battery pack costs is represented by the bill of material, does this percentage mean a reduction of cost overall of the 2 to 4%?
I don't have the slide here, but I think the purpose on what concerns time and cost reduction in MARBEL project focuses especially in what concerns the assembly phase to facilitate the assembly, and what concerns, for instance, the cost on testing and validation. No, for instance, one of the innovations that will be explained today try to save cost and time in the validation when developing new battery packs and performance. So it was more on building a design that facilitates the assembly and reduce the cost. Also in the maintenance, also in the life stage of the battery.
Very, very good. If I maybe can add something, MARBEL project that do not focus, this was explained by Edward before, does not contain anything concerning the battery cells. So all the research is done around the battery cells. So in principle, these cost reduction represent all the battery pack without a battery cell, of course. So of course, if we have thousands of euros of battery pack, cutting out not the bill of material, rather the battery cell, the ambition was to reduce that cost slice on all the rest around. So I can say that the cost saving is a bit larger than 4%, is the ambition was. Okay, and other question to Nello. I try to understand as well. This is general sense, also including the geopolitical things and all the pushes that the new condition gives on the electrification targets. So European Commission has issued some strict targets on electrification, but probably the geopolitical things are show some concern. In your opinion, do you think that rumors about the reintroduction of the diesel engine is something feasible, or?
Okay, so this is a general overview and related to the strategies of Stellantis. Obviously, there are many rumors internally in the company, but also at the European level, about the target that we have to stop the production of a thermic engine for the next 10 years. At the moment, there are some rumors to change a little bit the strategies internally, and maybe to push more on hybrid vehicle. So we want to obviously to be in the market with a fully electrical vehicle, with BEV at a worldwide level, obviously. But there are also some new investment and in design of hybrid vehicle. This is in order to not going back to the thermal engine 100%, but to have a mitigation moving to the final target of the electrification. So this means that basically we have in our plan, in our program, the design of new hybrid vehicle, and we believe that probably the amount of this vehicle will increase in the next years.
Okay, thank you. Other question from the audience? Otherwise, the list is very long here. No one want to dare? Okay. So I try to read it. It's very small.
Becoming old.
Yeah, I'm becoming old. Yeah, definitely, unfortunately. So are you managing material only for the battery cell or also for the e-motors and battery housings?
We are managing basically all the material. So 100% of the material for the battery cell. So as I explained to you, and there are here the team that work, because here we have in Torino the global team for the battery cell, but we manage also the material for the battery pack. I mean, as I told you, the thermal separator or different material that allow the electrical conductivity. We manage the material for the EDM, that both are for the e-motors, so rotor, stator, permanent magnets, and electronics, because we have also the issue of the electronics. High voltage electronics and low voltage electronics are become more and more important for the chip, for the transistor, for the material that we have in the PCB. And we are also investing in this material for the fuel cell, because we have also a team in Germany that specific focus on the fuel cell and hydrogen powertrain, and obviously the coolant. So it means that in my team, basically, we are engaged in all material that enable the electrification.
Okay, thank you. Do we have still time for other questions? Or yes. Okay. Okay. So I think this question comes from some co-workers, I believe. So relating to the Dare Forward program you showed, you said that there is a commitment to introduce decarbonized and recycled material in our final product, that in our case is the powertrain. Do you think that it will happen even if this entails some extra cost versus the virgin material?
Yes, okay, this is quite a really interesting question. So basically we have, I try to explain to you that our target for the material are obviously performances, cost, but now we have also the sustainability. Sustainability is becoming one of the 3 key indicators for the choice of the material. When we're talking about obviously the sustainability, we are talking about recycling material or material that have a low impact in the at the environmental level. So we are working on that. We have a roadmap to do this in order to introduce in our vehicle this material, basically, or with amount of recycling or material that can be recycled easier. At the moment, the strategy is to introduce green material, but I think that in the future we started to increase these activities exactly to reduce the potential cost, because today we notice that the cost of green material is higher than virgin one. And this is obviously an issue, but we are also working in order to introduce other kind of indicator, because to the moment for the material we are considering only the CO2 equivalent, so the CO2 emission, but there are some strategies in order to introduce also other kind of indicator like acidification or water consumption, because the impact in the at the environmental level is not only the CO2, but there are some other impacts. So we are working on that. We're working on that, considering obviously the cost, considering obviously the performances, but we are obliged, so we have to introduce this new sustainable material, and so we are working to map and to analyze this material in order to find the right substitute.
Very good. Ed, so MARBEL has reached its end. What next?
Well,
this is mine.
Well, I try to summarize a bit, in the presentation. Well, in electric mobility, there are many challenges from the ones presented, by Nello in the perspective of the OEM, the raw materials, how to bring this technology here, and also how to. I included for the case of aluminium, but I think that there is a critical concern, at least here in Europe, in what is concerned the leakage of raw materials, aluminium, but also critical raw materials, and all these materials that came here in Europe and became a battery, how we make to keep them here and not lose them. No, so there is quite efforts in what concerns the technologies for recovering this kind of materials. Also, this topic related with the indicators for sustainability, so considering not only the impact on how we get the material, but also considering what's the life of this material during the use or the service in mobility, and maybe also in enlarging the service to other second life applications. And for this, there is also need for traceability data platforms, traceability of the data and like having a link all through the value chain from the OEMs, the end users, the second life end users, that they can have real and transparent and traceable data to know exactly the state of life of the equipment, the materials that came to the second life, etc., to enhance this. And also the last part that I mentioned about the logistics and facilitating an ecosystem in Europe for transferring these components and extending their life, so reducing their environmental impact.
Very good. Maybe time is running out, but maybe I like the future more than past, and I would like to place another question if we got time. From Eurocat, your company or research center, we received. I know that there is expertise in this novel disruptive tool that is the artificial intelligence, and also ourselves, Nello's group is working in trying to take to get this tool for revolutionize somehow our way of conceiving our product. So is there, and on what maybe topic you think we can start conceiving a new future project on artificial intelligence? So how to have it integrate in our business? This for you, for you both.
Okay. Well, in our case, we have some AI applied in our project, but from colleagues that we collaborate with them, it's the ICCS center in Athens, related to the National University in Athens. And in Eurecat, so what I see AI in the domains, it's on saving time. For instance, on prediction of, in this case, this digital twin we built in MARBEL is for prediction of life of the cells and the battery, but also in what all concerns the simulation and models for simulating any behavior of materials, also maybe on thermal heat exchange, etc. The combination of simulation and models with AI can have a potential for reduction of time and resources for running this kind of simulation. Is something that can it's a thing where the technology can have an impact. As of the idea that came to my mind first would be this one.
Yes. Basically, we worked with the AI in the past to apply to the test, to the lab. We applied to the polymer, especially in order to avoid and to save time of test, avoid some tests. We had a huge database of material, and with artificial intelligence, we predict basically some test of material, some result of specific material if we change the composition of the plastic. So this was the first application of the artificial intelligence in our lab. Now we started to think how to apply to the material, and the new scenario are obviously to apply to. We started to work on the magnets. The problem that we have in the magnets are the high cost of our hertz. And so we are trying to understand with our result in the lab and with the generative artificial intelligence how to manage the performances, reducing the amount of the rare hertz in the e-motors. And this is quite important and giving benefit to the company and to our team, because we have to introduce less material and we have a cost saving. The same things probably we will do in the next year on the battery cell, on the cathodes or on the anodes, in order exactly to prevent the different composition of the cathode and anodes, maintaining the same performances. And finally, as I told you, the environmental issue is one of the key points that we have now on our desk, including cost, performances, and also the part of environmental issue. So we're starting to think how to use the artificial intelligence to help us to identify the best material. because I told you we have different indicator, we have different material, so we have a huge of data in terms of material and performances, different indicator of environmental impact. So we believe that probably the use of artificial intelligence will help us the choice of the best material in terms of performances, impact, environmental impact, and as well as cost. So this is basically what we did and what we want to do.
So let's do a project.